let's explore the complete architecture. The diagram shows how all the components integrate into a cohesive zero trust framework. Let's walk through each layer one by one. So at the top, we have AWS organizations. So AWS organizations help us, it's a parent organization underneath which we have created multiple AWS accounts. AWS organizations help us ensure that all of the child AWS accounts get the same amount of security. So we have created five specialized accounts here. The first is logging OU, dev test OU, production OU, security OU, sandbox OU. So under organizations, we have five operational units, and each operational unit for our purposes has one account. So logging account, so logging OU has one logging account, dev test OU has dev test account, production OU has production account, so on and so forth. There are different service control policies, which we can see here in the red. The first one is deny root actions. What this means is it prevents any of the AWS accounts or any of the users from using the root credentials. And this is across security and production. Then we have geographic restrictions. So in the sandbox OU, we can only limit any resource creation to specific regions. So let's say we don't want uh, any resources created in China or India or South America, we can do that. So security services protection, this prevents disabling guard duty. Guard duty is an important feature that we have. So no AWS account can disable that. It has to be enabled. Then if I scroll to the left a little bit, we have the AWS IAM Identity Center. It's a central place. It's an AWS service, which is central place for all IAM related things. So here we have created a few permission sets. Here you can see read-only access, which is valid only for 1 hour. So after 1 hour, you have to re-log in and re-authenticate yourself. Developer access is for 1 hour, CloudOps access is for 1 hour, dev test account access is for 8 hours, security access for 4 hours. Now we see different users created, like Alice user, Bob user, these are the test users. They are part of the admin group, and they will have access to this CloudOps role, which is kind of your admin role. Then dev test engineer, dev test group. So a dev test engineer should never be able to get the cloud ops access role. He should or they should only be able to do things specifically mentioned in the IAM role attached to this dev test group. So then each account that we have has a different purpose. So security account that we have here, this runs the security hub and it aggregates findings from the different accounts from guard duty, config, inspector, all of these are different security AWS services. And then we use machine learning to do threat detection. Like it can monitor CloudTrail, VPC flow logs, DNS logs, the requests coming into the application, etc. It does continuous compliance monitoring and it detects if there are any shifts in the resource permissions. Like let's say somebody raises more permission than they are required, then it can also raise that. Then we have the logging account that we see here. Logging account will contain logs from all accounts, CloudWatch logs. They will be real-time logs, which can be used for alerting and monitoring. We can send all of those logs to OpenSearch, so you can do quick text searches on the logs. And then to do all of this, we can stream logs from CloudWatch to OpenSearch using Kinesis Firehose, which is a streaming data pipeline that AWS provides. And then we have the production account. So production account is in a single VPC. It's isolated from all the other VPCs. So even if one of the VPCs has some issues, there will not be any horizontal access from those accounts. And then there are dev test and sandbox accounts, which are regular accounts, lower privilege, so you can do more stuff over there. Now, if we go all the way to the left hand side here, we see that there are three VPCs. So each VPC, as you can see, has specific subnets. So app subnets, DB and log subnets. There is a transit gateway here. So transit gateway is the only way that the VPCs can talk to each other. And it's a hub and spoke model where you can do centralized traffic inspection and you can disallow any traffic that you don't want to allow. And these all of these are private subnets. So maximum security in each of them and maximum isolation. Okay, so let's talk about the security monitoring and analytics. The findings or the logs findings that we have come into guard duty. Guard duty findings are being sent into event bridge rules. Event bridge rules allow us to filter and route findings depending on the severity that we have. And then we have some risk scoring lambda functions that calculate risk based on severity, resource criticality, historical context. So event bridge rules allow us to trigger that risk scoring lambda. And then all of that data gets stored into security findings S3. We can use Athena Analytics. Athena is the AWS service which interfaces SQL queries, so you can run SQL queries on your S3, and then you can display all of the risks and compliance metrics on the QuickSight dashboard that we have. Moving on to JIT access authentication here. So anytime let's say Alice user wants to log in as CloudOps access user, the first request comes to this JIT create lambda function. It receives JIT access request, then it creates time limited SSO. So in this case, it would be 1 hour, CloudOps access 1 hour. And then it stores the expiration in DynamoDB table and it tracks all active assignments that we have. And then if the time passes, then it just cancels that expiration. So the user is no longer able to use this. It runs every 5 minutes through event bridge schedule, and then it revokes any expired assignments that we have. So now coming down to automated incident response, we have three response playbooks. We have isolate EC2 lambda, which contains compromised instances. It takes forensic snapshots, and then this lambda, if it finds anything, then it applies denial policies to that S3 bucket, and then this revoke IAM lambda will deactivate compromised credentials. Yeah, and all of this eventually goes into another S3 bucket, which is the forensic S3 bucket, and you have the event bridge integration with all of this. You have the lab VPC where you can do you can investigate what may be happening. So it's an isolated environment for that. You can use Linux or Windows virtual machines to do malware analysis and incident resolution, and all of it is, as I said, it's inside this forensic history. So now let's take an example of a live event. Right? How would this work for a specific event? Let's say we are in a dev test account where a user has started an EC2 instance, and on that EC2 instance, they are doing cryptocurrency mining. So this is a high severity finding. So what will happen in this case is guard duty has a functionality to find that since it's high vulnerability. So security hub will send that information to guard duty findings, and then guard duty will trigger event bridge. And event bridge, since it's high severity, it triggers the isolate EC2 lambda function. The lambda creates quarantine security groups. It isolates the instance, the dev test instance where the cryptocurrency mining is running, and then it takes the EBS snapshot just for protection, and then it logs that into this forensic S3, and simultaneously it can also go to score lambda where it figures out what the risk is. In this case, it would be very high risk, and then of course it can you can do Athena analytics on that and QuickSight dashboard. So from detection to containment, it will take around less than 2 to 3 minutes. So this is the power of our uh, feature that we have here.